So the Dijkstra algorithm runs like this. You have a distance vector which tells you the distance from the source node to every other node in this graph. So that will be from 1, 2, 3, 4, 5, 6 and 7. So this vector, I've just noted down the indexes over here, is going to be telling you the distances from these cities to the source. So that's just one vector that we have. Alright, what else? We also need to have a set, a visited set. So that's going to be over here, visited. Initially, none of the cities are visited, pretty good. In fact, you can say source is visited, but it doesn't really matter. So, what comes next? You take the city closest to you, closest to the source in this distance vector. So, let's just note those distances down. That's 5, what else? 3 gives 10, 2 is connected by 16, 4 is connected, great, that's 12, and 5 is infinity because there's no direct path to 5. So we don't know what the distance is, so we just mark it as infinity. 6 is infinity and 7 is infinity. 6 and 7, yeah, they are not directly connected, so it's infinity. Your visited set is null, or empty rather, and now what? You take the smallest distance from the source to that city which doesn't exist in your visited set. Right now nothing exists. So the smallest distance is 1. So that's nice. You go to 1 and you try to contract everything around 1. You try to use 1 as an intermediate city to get to other cities more efficiently. But unfortunately 1 doesn't have any city connected to it apart from the source itself. So nothing happens. 1 gets added to the set and that's it. Okay, now these distances are updated. What's the next city which is not in the visited set and is the smallest? That should be 3. So 3 is taken into consideration. Now you're going to try to add 4 because that's the only connected city to 3. 10 plus 4, using 3 as an intermediate, 10 plus 4 versus 12. Not going to work. Nothing happens. 3 gets added to the set. The next city which comes in is 4, so that's 12. 3 is already added to the set. You have 5. So 12 plus 7 versus infinity for the distance of 5. So that's going to get updated. That's going to become 19 over here. Alright. And is there any other city connected? No. So 4 is added to the set. And now you have the shortest distance being, so 4 is already added to the set, 1 and 3 are already added to the set. Shortest distance is 2, 16. So taking 2 into consideration, you have 7 being given a distance of 20. So 16 plus 4 versus infinity. So 7 is going to become at a distance of 20. And there's nothing else connecting 2, so 2 is also added to the set. Now, what's the next city? 5. Because 5 has a distance of 19 and it hasn't been added to the set. We go to 5, we see that 5, when you try to contract with 5, it becomes 6 is one of the cities, which is 19 plus 9, so that is 28. For 6, 28 versus infinity, 28 wins, and you have nothing else connecting 5, so 5 is added to the set. Okay. Now, what else? The only cities remaining are 6 and 7. 7 has a value of 20 which is less than 28, so you pick that up first, and it gives you a value of 28. No, rather 7 is still there. So the only city which can be added or contracted using 7 is 6, and it's giving a value of 28, which is not less than 28 itself. So nothing happens, and 7 is added to the set. Now 6 is the only city remaining. There's nothing to do really. So 6 is also added to the set, and your visited set is complete, and you have these distances from the source node to the destinations.